There we go, and we're recording, and so this is our official start of big data for today. Welcome everybody. There's two things really that we want to, or that I want to go over today, and they're going to be things that you'll need for your sort of lab/homework assignment this week. So as a reminder, there's no sort of distinct lab this week. It's all just kind of rolled into one in this homework assignment. And but we'll still have the lab time on Friday at the normal time this week from 10 to 11 a.m. And you're welcome to attend or not attend. But if you do choose to attend, you get that 2 days extension on the submission. Before getting into the sort of material for today, are there any questions about anything administrative-wise or content-wise that we've gone over? Okay, then I will, well, I guess I have one other real quick announcement, and that's that last week I hired a grader for this course, and the things that she'll be grading are just the assignments that get put onto GitHub that have the automatic grading system with the continuous integration system, like we did in that week 0 assignment. Other things that sort of have any sort of ambiguity involved, I'll be grading those assignments myself. But if you do ever have an issue with your grades, always feel free to contact me and just send me an email, and I'll fix it if there's any problems. Okay, so I'm going to share my screen now. And I have pulled up our week 2 webpage, and I'll just scroll down real quickly, remind us what we covered last time. So we talked about this Instagram tech stack and kind of all of the different components that go into it. And again, the main sort of part of this course going forward after this week is going to be talking about this database component, in particular the Postgres database system. But this week we're talking about using Docker, and specifically Docker Compose, to kind of bring all of the components of a full-fledged web app online at once in an easy to manage way. And so it's bringing on all of our web service stuff, and it's bringing on our database stuff. And again, starting from next week, we'll be using Docker Compose to launch these databases for us automatically. And your homework assignments will have sort of built-in test cases that work with combining Docker Compose with these test case systems. This week's homework, though, does not have those test cases. That this is really just another chance for you to get the practice of sort of the system administration aspect of these things that you need to do in order to complete those future assignments. So how do you actually bring these things up and bring them down, and in a way that you're not going to lose your data? Yeah, so that's kind of what we were talking about. And yeah, so this Docker Compose program, again, we saw that these are the commands that you'll have to run on your own side in order to get access to this Docker Compose program. And we talked a little bit about using it to take down a service and build a service and bring it back up, and that these were kind of the steps that you had to go to every time that you were making changes somehow to one of the components of the system. The two things that we're going to talk about today are, so we'll continue talking about all of this kind of stuff right here, how to effectively make changes to your code, and in particular, we'll be introducing something called Docker volumes, which let us, if we're in sort of a development environment, not have to go through this sort of procedure of bringing the system down and up again, because that slows down our productivity. We'd have to wait, I don't know, a minute or so every time we make a change, and we don't want to do that. We want to get the quicker feedback so we can iterate faster on our development. So that's what we'll talk about. One of the big things that we'll talk about today. And again, the key word for that is Docker volumes. The other major thing that we'll talk about today, and this is actually what we're going to start with, is these credentials in Git and how this can introduce security issues into your any applications you're developing with Docker, whether it's a web page or something else. And there's a lot of potential security issues with Docker. Here's 3 just kind of really big ones that we're not going to talk about in class, but if you have a goal of, say, being a CTO at a company one day, so being in charge of the production systems, then these are things that you would really, really need to know in order to prevent security breaches at your company. So I'd highly recommend looking at these, but this is the main one that we're going to talk about in class. It's also going to have a very important effect on your submission for your homework that's due this week and all your future homeworks. And so I'll talk about that, how it affects the homework as we talk about exactly what this is. Again, you all have been doing a great job of, when you have questions, interrupting me and asking them. So continue to do that. Continue putting your questions in chat as well, and I will address them there. But before we talk about actually this credentials issue with Docker and Git, are there any questions right now? Okay, so I'm going to switch our screen then over to the terminal again. And you can see that I'm logged in 2 windows, 2 terminals, kind of like normal, and both of these are in the same folder that I was working on last time, this Flask on Docker folder. And as all of these files in this folder are structured the same way that the homework files are going to be structured. And what I want to look at right now is, you notice that, so on the left-hand side over here, I did ls-r. On the right-hand side, I'm going to do ls-ra so that we can see the hidden files as well. And I want to focus on these hidden files right here. These files that start with the .env, the env stands for environment variables. So these are the files that define environment variables for us. And in particular, I want to look at this env.prod.db file. So I'm going to open that up, .env.prod.db. And inside here, there's this one really important line, what our password to our database is. And you can see that it's a pretty complicated password, not something that anybody is likely to randomly guess or brute force guess. That the password is long enough, it has enough entropy in it that it would take multiple lifetimes of the universe to brute force guess this password. Yeah, so this password, if somebody were to attack your system, trying to get access to your data in an unauthorized fashion, this is sort of like the golden ticket, the thing that they want. And in a typical, say, startup environment, or really any technical company, the CTO of the company is going to be the only person who has access to this password. They're going to be the only person who controls who gets the ultimate sort of root authority on the database. And so we're going to talk about now how sometimes people accidentally give people this password when they shouldn't have this password. And the main thing that one of the main ways that this comes up is with Git repositories. So right now, this entire project is not contained within a Git repository, but as part of your homework submission, you'll have to submit a Git repository that contains your project. And so I'm going to go through the steps right now of how you can create this Git repository and ensure that you're not going to accidentally put these production credentials into the Git repository. So the command to create a Git repository is git init. And you can see it just created an empty Git repository for us. And if I were to run git status right now, so git status again shows all of the files that have either been modified or are somehow not included in the current state of the repository. And you can see that here's all of these files here, my Docker Compose files, all of these environment files that we were just talking about. There's this file right here, .swp. SWP stands for swap. And this is a file that's created automatically by Vim when you open another file. And so if I close this database file right now and rerun the git status command, you notice that SWP file no longer exists. It's no longer something that wants to get added to the Git repository. But if I reopen this, there it is. Rerun this, there it is again. And so now actually there's two different files right here that contain this very sensitive information about what this password is right here. It's contained in this file directly, and it's contained in this swap file right here. So these two files right here are things that under no circumstances do you ever want to have added into your Git repository. Because if they are, and your Git repository is public, or some other way people get access to your Git repository, then they'll have access to your production database credentials. And even if you have, say, a private Git repository, you might think that, okay, it's not too big of a deal if I put my production credentials in there, but there's thousands of stories where you either have a malicious insider who got access to the credentials and then they did something bad, or even you have a just somebody who's not a accidentally, no malicious intent, but accidentally uses the credentials to do to delete your production database, and like the company is devastated because of that. So yeah, these things that you want to protect, not just from potentially malicious people, but even from people that you trust. It really should be only one person, only the CTO, only the person who is ultimately responsible for the data integrity of the company who has access to this information. Okay, so the key way to, or the simplest way to protect this, the way that I recommend you do this, is to create what's called a Git Ignore file in your repository. And the Git Ignore file tells Git never to put files that match a certain pattern into your Git repository. So on the left over here, I'm going to quit out of Vim, and then I'll open this up like this, Git Ignore. You notice that it's also a hidden file. It starts with a dot. The name of the file is Git Ignore. We just pronounce it as the Git Ignore file, and we don't say the dot. So it's not the .git ignore file. It's just the Git Ignore file. If I hit enter, and now any file that I type in here is something that Git will never add to the repository for any reason. So I definitely want this environment.production.db file in there because it contains that sensitive information. And now I save that, so :W on the left, on the right-hand side, rerun git status. And you notice that, so the Git Ignore file is contained in here now because I just created that file. It didn't exist before, so that's why it was not up here. But now this env.prod.db file, it still exists in the folder. It still has something that we can use and have access to, but it is not contained in this list of untracked files that Git wants us to add. And so now if I do something like git add dot and git commit -m first commit like this, then I've just added all of my source code files into this repository, but I have not added the database file itself. This is still not quite actually a good enough Git Ignore, because remember that, so now on the left-hand side, I'm going to open up my production env.prod.db file, the file that contains this password right here. And now if I run git status again on the right-hand side, it shows again that it created this swap file. Vim created this swap file. And this swap file contains all the contents of the original file. It's sort of like a backup so that if you lose power or something, you can restore from whatever changes you've made. And so this is another file that we need to not include in our Git repository. And so the one way that we could do that is we could explicitly list all of the files that we want to exclude like this. But now let's, on the right-hand side, rerun this git status command. And you can see that, okay, the git ignore and the git ignore.swap are in here. So this is not in here as well. But we probably really don't want any swap file to be contained in this repository. And so rather than having to list out all of the files that we don't want to include and then putting .swp at the end, Git Ignore supports the glob, just like Bash for patterns. And so recall that the glob is this star operator, and if I do star.swp, then any file ending in .swp will no longer get tracked by Git. And I run git status again. Here, this file was added to Git originally before I added the created this Git Ignore, so that's why it's still trying to track this file. But if I were to say create, let's open up the Docker Compose file like this, run git status, you can see there's no swap file for the Docker Compose, even though if I run ls-a, there is the swap file. So for your Git Ignore, I recommend that you have something roughly looking like this. At the very least, you need to ignore your .prod.db file, whatever file contains your password information. And you probably also want to ignore all of the swap files like this as well. This, for ignoring swap files in Vim, start.swp is not quite enough. That I'm going to open up another Vim instance right now. So on the left-hand side, I'll press Control-Z, send that Vim to the background. If I type PS, you notice that the Vim is still running right there. But I'm going to open up a new Vim instance right now, Vim, and let's open up the Docker Compose file again. And there's no dot in front of it. There we go. So Vim Docker Compose. You may have seen this error message before when you're opening up a file in Vim. What this is saying is that it's already opened somewhere else, and it knows that because this .swp file exists. And so there would be this option to recover from that SWP file. So that's what it's for, so that you can recover if something bad happens. But in this case, I'm just going to do the edit anyways, like this. And now what I have is two Vim windows, two Vim sessions editing the same file. Both of those Vim sessions need their own swap files, their own swap information. And so now if I run git status, there's this docker compose.yaml.swo file in there now. So it used to be swp. O is one letter after P. So after SWP stands for swap. After we're done swapping, we go to swowing, SWO. Close that. It's not there anymore. FG, bring the Vim back up. And so instead of just SWP, O, something like that, so that you can have up to 4 different versions of the file open without accidentally adding those into your repository. And again, this is important because if you're opening this file, any file that contains sensitive information, you can't just block that file. You have to block all of the possible files that Vim or whatever other programs might be using that file to contain information. So yeah, if you have a Git Ignore like this, this is essentially the main tool that I use to prevent myself from accidentally putting credentials inside the Git repository. Are there any questions about this? Okay. So how exactly this relates to your homework? This is a very key thing to pay attention to right now because it will affect your grade and it can have a potentially enormous impact on your grade. So all of the Git repositories that you'll be creating in this class, the vast majority of them from here on out will somehow have credentials inside of them. And it's incredibly important that none of these Git repositories, for any reason, have credentials inside of them. Yeah, you can read my little statement about security breaches. You can see some of these examples. But the takeaway is that if your repository in any way contains production credentials, you will receive -2 points on the assignment. And so this assignment is worth 10 points. And so notice that that does not mean you get 10 points minus 2 points for 8 points total. It means that you get 0 points minus 2 points for -2 out of 10. So you actually would be better off not submitting the assignment than submitting an assignment that contains production credentials inside of it. There's a really harsh penalty, and the harsh penalty is on purpose. Again, you can click this button, read some examples of companies that were dissolved because somebody accidentally committed production credentials to their Git repositories, and then it became public information, and people were either able to log in and just delete all their data or modify the data, or they were able to log into, say, their AWS accounts or their cloud accounts and just run up astronomical bills, mining Bitcoin or doing other things. situations that the companies could not recover from. So that's why this is so important, and I really want to emphasize this, that if you were working at a company and you were to commit production credentials to a Git repo, it would be better for you to have just like not done anything, because the company is very likely to go under if you do that. So this very steep penalty that's happening right now if you were to commit these production credentials is to help get you scared of this. You should be kind of terrified that your repositories will have production credentials inside of them. And that's sort of the right way to feel about this, is that touching that file, touching anything involving passwords should be a very scary thing. And you do not want them involved in your Git repositories in any way. Are there any questions about that, about the grading or the mechanics of that or anything? Okay, then we will go on to the sort of next topic for today, and that's kind of picking up where we left off with sort of the difference between, what we'll talk about today is the difference between a development environment and a production environment. Last time we were kind of working in something that sits between the standard development and production environments. But the key thing that we saw last time was that if you wanted to change your anything about your running Docker instances, you had to follow this step of down, build, up. So let's real quickly over here, we'll run through these steps again, clear out these screens. So I just typed the clear command. It's a simple way to delete what's on your terminal, give you kind of a mental fresh start about what is going on. But you notice that on my terminal, I still have the scroll bar here, so I could easily, oops, I guess on that one I can't, scroll up and see the previous stuff. On the right-hand side, I can't do it because I typed it twice to illustrate what it does, and it kind of deletes all the previous history. Okay, so I'm going to open up my docker compose.yaml file right over here, and then I'm going to open up my, so we have the services /web/project/dunder init file like this. And we made last time this new change, adding this example route. And in order to get this example route to be something that we could see, we did that docker compose down, docker compose build, docker compose up kind of cycle. That's a little bit annoying of a thing to have to do. We would like to be able to just kind of directly modify what's going on. And so we'll take a look now about how we can do that. And so on the right-hand side over here, still in the same folder, still have all the same files. And we'll start by doing docker compose up, bring the web page up. There it is. Come back over to our web browser, refresh that. Okay, so we're able to connect, that's great. And now on the left-hand side over here, let's just change this hello world to a goodbye world. That's sort of my standard thing that I do when I just want to make a simple change to something, and refresh over here, and we notice that it's still hello world. So in order to dive a little bit deeper into what our goal is that I can just modify this file exactly where it is, and those changes will happen instantly. And in order to see how to do that, first notice that on the left-hand terminal over here, I'm directly connected to the Lambda server. I'm not at all connected to the Docker image. And so what I'm going to do right now is connect to the Docker image. So Docker PS lists all the running Docker images. There's two that are currently running. One is my database that has Postgres. Here's the name of it, Flask on Docker DB. And the other is my web service, Flask on Docker Web. The web service is the one that contains the files for the actual web page. So that's what I'm going to connect to. And I'm going to do docker exec-it. Here's the name of the service that I am connecting to, and I'm going to run bash. And now I'm connected onto into that Docker image. Here, if I run the ls command or the ls-r command, you'll see that the contents here are the same exact contents that were in the services/web folder on the main Lambda machine. And so to illustrate that, I'll Control C over here, ls pwd. Let's go into, let's do ls-r services/web, and you can see that everything over here matches up with everything over here. And the reason for that, again, is that inside of this Docker file for the web service, so I'll open that up, services/web/Docker file, there was this copy command right down here. Copy command copies dot, so the current location, the current working directory, and the working directory, the working directory is the directory that the Docker file is contained in. So it's contained in the services web. So it's copying everything in services web, which is all of this, onto the Docker container, the Docker image. And where on the Docker image is it copying it to? Well, this path on the right. In general, the rule to sort of keep in mind when you're sort of doing these things is that the thing on the left is always whatever is closest to you, and the thing on the right is whatever is farthest away from you. So in the Docker file, when you're copying, the thing on the left is on the Lambda server, and the thing on the right is the Docker image. And that's because the Lambda server is closer to you than the Docker image. In order to get to the Docker image, you have to first go through the Lambda server. We've seen that sort of pattern before with the port situations. So here's the Docker compose file. This maps port 3400 on the Lambda server, the thing that's close to you, to port 5000 on the container, the thing that's far from you. The container is farther from you because you have to go through the Lambda server to get to the container. So the left, whatever's closer to you, the right, whatever's farther away. And so that's how all of these files ended up getting on here in the Docker container. I'm going to close out of this, :QA, and now, so Docker PS again on the right-hand side, there's nothing running. Let's re-bring up the Docker service. So Docker compose up. This time I'll do it as a daemon -d like this, just so that we'll be able to keep running things as we like. And now over here on the left-hand side, I'm inside of the Docker container, and if I want, I can edit the files inside of the Docker container. So here, this init.py is the file that contains all of the web page information. And so vim project, let's see, ls vim, oops. I guess when let's see. Yeah, so what happened was that I was previously connected to the Docker container. On the right-hand side, though, I closed the Docker container. And so because the Docker container closed, my connection to it was shut down. I know that it was shut down because when I was inside of the Docker container, let's see, right here inside of the Docker container, this is what my prompt looked like. It ended in the hashtag. The hashtag sort of a non-standard prompt, but it's what sort of traditional for Docker containers, just as a reminder that you're inside of the Docker container and not in your standard shell. My standard shell prompt right now from that PS1 variable is the $. So I noticed that I got sent back to my Lambda server shell because it's starting with a $. So I'll use the up arrow again to get back here and reconnect to the Docker container. Now I have the Docker container prompt. Here's the ls. ls project. This project /dunder init is what I wanted to edit. There we go, vim project /init. You can see that we're getting this message because not only did Docker copy over the init file itself, it also copied over the swap file. And so I could either delete the swap file or just edit the file anyway. It doesn't really matter, but I'll just delete the file, press D right there. And now this contents right here on the left-hand side is exactly what we were looking at before. You notice that my Vim window is a little bit different. I don't have the numbering on the left-hand side. None of my Vim settings actually are applicable right now. And that's because I'm inside of the Docker container. I am not on the Lambda server. I SSH'd into the Lambda server, but then I used Docker exec to connect into the container. And so none of my settings from the Lambda server are applicable here. Okay, so we had this hello world right here, and this is the file that's actually being run right now. So I'm going to change this file from hello to goodbye, and let's just so it's something totally different than what we've seen before. Goodbye, cruel world. Save that, :W. Now back over here into my Firefox, refresh this page, and now that update has taken effect. So in order for an update to take effect in a sort of a quick, efficient way, you have to make that update on the container itself and not on the Lambda server. If you make, sort of the takeaway is that if you make any changes on the container, they happen instantly, and there's no need to do this container down, container build, container up cycle. Are there any questions about that?
Yeah, so if we make these changes on the container, then like when we close the container,
Sorry,
build is
Safik, I missed the start of what you were saying to volume issue. Can you restate it?
Oh, so yeah, so I was saying that if we make these changes directly onto the container, then once we shut the container, we lose the change.
Exactly, and that's a great observation. That so recall that with containers, one of the key defining features of a container is that they don't really save any information. That when you want to make something permanent about a container, you have to put it in the image for the container, and the image is what's defined in the Docker file. And any changes that you make just to the what we would call the running instance of the container, those are ephemeral changes, and they will not be permanent. So over here, let's illustrate that right now. We have these running containers, and if I were to say Docker PS, there they are, they're running. I'm going to stop these containers. So Docker compose stop like this. That shut down these two containers. Again, I was in a, on the left-hand side over here, was connected to the container, and it's a little bit confusing now because I was actually inside of Vim while I was connected, but you can see this $sign right here, and whoops, now every time I click, some like weird things are happening, and that's because my connection was sort of interrupted, and so the terminal is kind of in a weird state. Anytime your terminal is in a weird state and you want to reset it back to a fresh state, you use the reset command, R-E-S-E-T. And things will look weird. You might get some weird messages, but if you type reset, it'll all clear up and be back to normal. And yeah, if we were to say, for example, now open up the services/web/project_init, the file that I was editing on the inside of the container, you'll notice that those changes did not affect anything on the Lambda server right here. You also notice that if on the right-hand side, so I just stopped the previous containers. I actually wanted to use the down command. Now if I use the up command, yeah, so stop is something slightly different from down, but down is what we were using last time if we did Docker up and then Docker build and Docker down. Maybe we'll get to what's the difference between stop and down here in a minute, but Docker down is sort of the standard way to bring your containers down. And now if I do Docker compose up again, like this, and there we go, it's running. And on the left-hand side, I'll reconnect with this exec. And right now what I'm doing is I'm using the up arrows to try to get to my previous command history. And the first thing that is kind of annoying is that there is no previous command history, because even though I was just connected to this container and was just typing in commands, the container was went down and brought that up back up. So all of the changes were deleted, including the history of things that I've typed. So I have to type it out manually, vim project/dunder init.py. That swap file's still there, delete that, and you notice that this change is back to hello world. It's not at the goodbye cruel world. So to get the really fast iteration, you have to edit the container itself, but that's also really bad because those changes are ephemeral. They're not persistent. If you stop the container, bring it back up, you've erased all your changes. In practice, it's very rare for developers to actually directly interact with a container like this. Usually sort of only the most extreme kind of debugging situations where you need to like really understand at a step-by-step level what is going on, and you want the changes to actually be ephemeral. That's kind of the main thing that happens. It's also would be the case that like in your production environment, you have an active attack going on. There is a hacker logged in, and you need to somehow get them off without bringing your services down and interrupting services for other actual customers. Those are sort of the only two situations where it's sort of like good to be manually running commands on a Docker instance. So what we're going to talk about next is what are called Docker volumes, and Docker volumes allow us to sort of bridge this gap of letting us do really quick iteration on a Docker container without having to bring it up and bring it down over and over again. And it also allows us to make whatever changes we are making, have them be persistent, so that, we can actually keep whatever changes we make. Before we go into exactly what the Docker volume is and how to use it, are there any questions about what we've seen so far? Okay, so I'm going to quit out of here, Control Q on the left, and exit to log out of the system, or log out of the container, still in the Lambda server. And now ls, and I'm going to open up my Docker compose.yaml file like this. And you can see on line 7 and 8, I have commented out this, this volumes command right here. Maybe before we talk about exactly what this volumes command is doing, let's talk about what all of these other commands are doing. So inside of services, I have two services, web and DB. Those are both the services that get started when you run the Docker compose up command. Build means that inside of this folder right here, there's a Docker file that needs to be built. And so this is what gets happen when you run the Docker compose build command. If you have image instead of build, you always need to have either one of image or build. Image is a image that's not provided by you. It's something provided by an external service, and Docker will download that image for you. So here, the Postgres database is something that's just provided for us. We're not modifying that in any way yet, although in the future we will be. And so we're just downloading this image right here from the internet. We talked about the ports. This is the Lambda server port. This is the container port, and the Flask system just uses port 5000 as its development port. This env file connects to those environment files that we were talking about before. So go tab e.env.dev. All of these are environment variables that will be available within the web host. And because they are included here and not included down here, they are only on the web container, not on the DB container. Here you can see that, there's a lot of things in here. None of these things are sensitive things like the database password. So some people might choose to include this file in their .git ignore. Some people might choose not to include it. It's totally like a personal preference thing, and doesn't really matter. The difference between this env underscore file and this environment is that here you can just manually specify exactly what the variables are. Here you include the variables in a file. Here you just list them one by one. And notice that here I am including a Postgres password, but this is sort of for a development environment and not including actual data. And the password's also just like a junk, easily guessable password. So in general, development sort of situations, it's okay to include the password because nobody would have access to real data with that. But the production situations, you don't want to include the password. Okay, well, I guess the last one is this command that if you're doing a build, this is the command that actually gets run when the service starts. If you're using the image, that has a command already built in, and so you don't need to have this command sort of manually specified. And this right here just says start the Flask program, start the web server so that people can connect. So what does volumes do? I'm going to uncomment this. And volumes, so notice that we have this colon here, and it follows the same pattern as the ports in the copy, that the thing to the left of the colon is something that is close to you, in this case, a location on the Lambda server. So this is a folder on the Lambda server. And notice that in this case, it's the same folder as my build environment folder, the same folder where the Docker file is located and the whole project. It can be any folder on the Lambda server, but it just happens to be the same in this case. And then the right-hand side is the location on the container. And what this does is it says, make these two folders be exactly the same thing. So that whenever I modify a file in this services/web folder, it will also modify that same file in the container in the /user/source/app folder, and vice versa. If I modify a file in this location, it will also modify the file for me in this location over here. So in order to demonstrate why that's useful, on the right-hand side now, I'm going to exit out of my running containers. Because I made some changes to the Docker Compose, I'm going to do Docker Compose down, and then Docker Compose build, and then Docker Compose up. And this time I'll go back into -D into the daemon mode. On the left-hand side over here, :tab E, let's open up our services/web/project/dunder init file. And then on the right-hand side, I'm going to go into the container and open up the same file. So ls docker, oh, yeah, docker ps is what I wanted, if I spell it right. Docker ps, docker exec-it, then the name of the service, Flask on Docker _web1, and then let's do bash. So notice that I'm in the location /user/source/app. So this is the same location that in the Docker Compose YAML /user/source/app. So I'm currently, I would say that I'm, this folder is the volume. I'm currently inside of the volume. My working directory in the remote or in the container on the right-hand side is the volume I have defined in the Docker Compose. And this maps to this /services/web, which contains this init file. And so on the right-hand side, if in Vim I open the init file, we'll see that it's the same exact file. And now, if I were to edit one of these files in one location, it should, in theory, make the same edits in that other location as well. So on the right-hand side, I'm going to close out of this. Let's open up again. Notice it says goodbye world over here. Close out of this. On the left-hand side, let's go to line 22, change that to hello world, and :W to save that. Now on the right-hand side, reopen this, and the change has taken effect. It now says hello world instead of goodbye world. And so because that change took effect on the container, even though I made that change on the Lambda server. The volume connected it to the container and made the change take effect on the container. I can go back over here to my Firefox window that has that open, refresh it, and it comes back to hello world. Yeah, so summary, this line of this volume connected my Lambda server, this folder, to the container in this folder, so that all of the changes that happen here automatically get replicated over here, and vice versa. And so that's why the change on the Lambda server affected the container, which allowed the web server to actually display the change. Are there any questions about that? Okay. So this is something that, like, when debugging on problems, it's really easy to get these volumes just like really slightly mixed up, and so that things that sort of should happen, like this propagation, aren't fully happening correctly. So if if something like this is not working for you, there's a very good chance it's just like one really tiny thing that needs to be changed, and then it'll start working for you. But it's very hard to find what that tiny thing is. And to help illustrate why that is, I want to take a look at this second volumes declaration down here. So there's 2 volumes defined in this Docker Compose, this one up here and this one down here. And at first, the syntax between these 2 volume declarations looks very similar. And you still have this volumes colon, still have a dash indicating a new volume is being created, a dash right here. Basically, for any of these things inside of one of these colon blocks, you just have a dash for each separate line, a dash for each item that you're defining. So whether it's an environment variable or a volume, the dash just indicates that it's a new, whatever that thing is that's being defined. And down here, we still have something to the left, colon, something to the right. In this case, this thing to the right is the location where the Postgres database stores all of its information. And it's the thing to the left that's actually different. And it's hard to see exactly why it's different, but the reason it's different is because up here, up top, it started with a /. Down below, it does not start with a /. And that's syntactically, that's the only difference. This is what's called a local volume, a volume that is created with a local path on the local machine that is running Docker locally. This down here is what's called a named volume. And in a named volume, you don't actually specify the location on your local server, or in this case in particular, the Lambda server. You don't specify the location where it's being stored. Instead, you provide a name that refers to the location. And again, the only reason we know this is a name and not a path is because it does not start with a /. If it started with a /, it would be a path. This does not start with a /, so it is not a path. And if you have something like this that is a named Docker volume, you also need this just section down here, which creates the named Docker volume. There are many different settings that you can put in here, but we won't be going over those at all. The main difference is that, so this Postgres _data, there is no folder in my current project directory corresponding to this data. So I'm going to do on the right-hand side, :Q. And if I exit out of the Docker container, so right now I'm on my Flask on Docker, type ls -r, you'll see that there is no file anywhere inside of here that looks like Postgres _data. Docker instead is managing this for you automatically. And in order to find out what all of the named volumes that you have in Docker are, you do the command docker volume. This is how you interact with your Docker volumes that are named volumes. The docker volume command does not do anything for local volumes or path-defined volumes. It only does it for the named volumes like this. And so if we do Docker volume ls, we can see that here is one created right here. That is the same one that we defined in this Docker file. And there's a couple of other ones, or one other one that I have defined as well right now. But this is the one corresponding to this right here. If I wanted to, say, actually delete this, any data in right here, say, for example, because you are running out of disk space on the Lambda server and you need to delete things in order to free up disk space, what you have to do is first bring your container down, docker compose down, and then you can do docker volume rm and the name of the Docker volume, like that. And that deletes it. And now if I do docker volume ls, it shows that it doesn't exist exist there anymore, and it has freed it up. Are there any questions about Docker volume so far? Okay. Let's see. So then the next thing that I want to talk about is a little bit more about the differences between a typical development environment and a production environment. So this Docker file that I have right now on the left is a typical development environment Docker file. And using this volume to connect my local machine, in this case the Lambda server, with the container is standard practice in a development environment. And that makes it so that you can really quickly iterate on, again, the development aspects. But in a production environment, we don't necessarily want that fast iteration for security reasons, and it turns out that it's actually a little bit less efficient having this volume set up this way. And so I'm going to look into, so on this project folder, we've only been looking at this docker compose.yaml file so far, but there's this file as well, .prod for .production. And let's take a look inside of there. And now, yeah, so this .prod.yaml file, production YAML file, is a standard, typical, what a typical production file would look like. And the first major change that you'll notice is that on the left-hand side over here, I had two services defined. I had this web service and this DB service. And on the right-hand side here, I now have three services defined. I have this web service, DB, and this further one, Nginx. If you remember, so I'm going to switch back over to the README file right now, that Nginx is our load balancer. Sits at the top. It's the first thing that when somebody connects to our web page, what they interact with. They hit that load balancer, and then the load balancer determines which web server they're going to interact with. So again, the Nginx makes our program a lot more efficient and a lot more scalable, because it allows us to easily add multiple web servers, and Nginx handles assigning new connections to individual web servers without us having to do anything. We didn't want it, though, in the development environment, because it would have prevented us from being able to do that rapid editing text just on the Lambda server through the volume and having it instantly appear. So Nginx is only running in the production environment. Yeah, so we have this /services/Nginx. On the left-hand side, I'll go ahead and go into that service. You see that there's a Docker file for it and this nginx.conf. We're not going to look into exactly what's going on, the details of these, but it's essentially just the settings for Nginx. And if you really were creating a website that was going to be like Instagram and have 26 different web servers that people could connect to, you'd have to modify this configuration file just a little bit to make that work. You'll notice that Nginx here has its own volume defined. This is again, a named volume, not a local volume or a path-defined volume. And this is specifically for files that are what we call static files, like images or things like that in your web page that don't need to have any processing from the web server involved. So the way that this Nginx configuration file is set up is that it can actually entirely bypass the web server for situations where there's no need to access it. The ports situation is the same. The left-hand side is what's close to you. The right-hand side is what's far away from you. But in this case, Nginx has a default port of 80. That's the standard web server port. And so that's why there's an 80 over here instead of a 5,000. And then this depends on is also something new. This ensures that the Nginx server will not start up until the web server is fully started up. And that's important because if back on this graph, if we have a load balancer, but the web servers haven't started up yet, then anybody who connects will just be getting error messages because the blue line can't fully connect. Are there any questions so far? Okay. So here, the web server, so this build has a slightly more complicated version that we can use. The context is still that folder that contains all the stuff, but now there's a different Docker file, the production Docker file, which just contains slightly different information inside of it. And notice this command now is not running the Flask web server, but it's running Gunicorn directly for us. And Gunicorn is that it's that web server that interacts with the WSGI Python framework, and it's significantly more efficient than how we were running Flask before with that development environment. The way that we were running Flask before, it's limited to having only a single connection at a time. So great for development, but very bad for production when you have thousands of people connecting every second. Gunicorn supports threading, supports multiple connections at a time, and so this is just a much better web server for production. Here, this bind command tells us who can connect. This 0 IP address right here says that everybody's allowed to connect, and this 5,000 says what port are we listening on. So Flask, the default was 5,000. Gunicorn, you have to specify what it is, and so we've specified 5,000 just to keep things consistent. And now down here on the ports, notice that there is only a single port listed here and not multiple ports. This means that it is impossible for us to connect from the Lambda server directly to this Gunicorn server or to this web instance. If we wanted to be able to connect, if I did something like 3401:5000, then if I connected on port 3400, I would connect to the Nginx server. If I connected on port 3401, I would connect to the web server, Gunicorn. But we don't want anybody being able to connect directly to the Gunicorn instance. So by only listing a single port here, that says that everybody who's on the internal network defined by this Docker Compose file, so all of these 3 services, can connect to the web service on port 5,000, but nobody outside of the Docker Compose file can connect to this web service. And again, that's just a little bit more isolation, a little bit more security, so good practice for a production environment. And then here, the actual environment variable files, and here this one in particular, that super sensitive one that contains our database password that you can't let anybody see the contents of for any reason. Any questions about any of that? Okay. So that's like all of the key important things that you absolutely have to to know after coming away from this week's work and this week's homework assignment that in next week, what we'll be doing is we'll have a, for your homework, I'll be providing you a fully completed repository with this Docker Compose file and a handful of services, and we'll start practicing working with the database in that file. And you'll need to be able to do this, bringing things up and bringing things down and modifying the files so that you can keep these changes on the database exactly as persistent as you want them to be. For the last 10 minutes of class right now, I want to talk about one of the differences between Docker containers and Docker Docker images. Exactly what the difference between an image and a container is, that these are a little bit confusing, and so I want to just make sure we talk about, or it'll be potentially helpful to you to clear up exactly what these distinctions are. Again, though, these sort of distinctions are not things that are ever going to be like tested in a final. All of this material from these first 3 weeks not going to be in any tests in this class, but just to give you the background information to understand exactly what's going on under the hood when you run these Docker Compose commands. So the key difference between an image, or the key idea of an image, is that it's what is defined by a Docker file, and it is the blueprint for starting a container. So you can have one image with many, many containers, and the changes to a container, again, never affect the underlying image. If you want to affect the underlying image, you have to edit the image itself. Which means edit the Docker file itself. A container, on the other hand, is a little bit more complicated than what we've been talking about so far. So in particular, a container or a container instance is what happens when you run this Docker run command, or when you do this Docker Compose up command. And actually, maybe I didn't mention this before, but here I have this -f docker compose.prod.yaml up. If you want to specify which Docker Compose file to use, you use -f, then the Docker Compose file. So this brings the production Docker up. And if you left out this and just did Docker Compose up, it defaults to the docker compose.yaml file. So yeah, when you run this Docker Compose up, it's actually creating this container instance from the image. And I want to talk a little bit more now about what this persistence inside of a container actually entails. So switch back over here to our Docker, to our terminal. And if I'm going to type Docker PS, and you'll see that currently we have no containers that are actually running. But just like with files, there are hidden containers in Docker as well. And these hidden containers are containers that they're not currently running, but they still exist in Docker's memory. And just like to display hidden files, ls-a displays the hidden files, we'll do docker ps-a to display the hidden containers. And right now, you can see there are no hidden containers. So we'll see, how do these hidden containers come about? If I were to say do docker compose up, so this will start the development containers for me. And so it's not in daemon mode. And now I press Control-C like this, and it stops those containers. And now docker ps-a, you can see that these two containers are still listed with the -a flag, but they are not listed like this. What that means is that the contents of these containers still exists in your system's disk space. It can still be modified and accessed, and changes to them can actually be persisted through this container instance. They won't go back to the container image. They won't go back to the Docker file and be changed there for future containers, but we can modify these individual containers as they are and bring them back up in the future. In order to do that, I'll bring them up again. Docker compose up. Then on the right-hand side, let's quit out of this. ls, let's connect to one of these containers, docker ps, docker exec-it, and then the name of the container right here, we'll do it on the database. I'll do it on the web, will be consistent. Web_1, and I have to put the command, I want to do bash, type ls. So here's the files of the current project. I'm just going to create a few, not full more files, example 1, example 2, example 3, example 4. The touch command, again, just creates files if they don't already exist. So now here they are. Example 1, 2, 3, and 4. Exit out of this container. And so log back in, those files are still there. Exit out again. On the right-hand side over here, Control-C to end this container. But again, remember Docker ps-a, those containers still exist. I haven't actually killed those containers yet. I haven't deleted those containers. And so if I bring the system back up with Docker compose up and reconnect over here and type ls, we'll see that these containers, or sorry, these files that I just created actually still exist over here. And actually, let's see, if I exit out of this, ls here, ls services/web, actually, they still exist partly because of this volume that I created. So I created them also on the Lambda server. So this isn't quite a good example yet. Let's reconnect here. And now I will cd into the slash folder, the root folder of the machine. So this is not part of a volume. And now rerun these touching commands. So now in the root folder right here, these still exist. Exit out on the left, Control-C on the right to stop the container, bring it down, bring it up again. On the left, reconnect and cd into slash and ls, and those still exist here, even though they are outside of the Docker volume. Now, the reason they still exist is because when I press Control-C on the right-hand side over here, it's not actually deleting the container. It is what we'd say in Docker terminology, stopping the container. So Docker ps-a, these containers still exist. That means any changes to them still exist in memory and still taking up space on our hard drive. In order to actually delete a container, it's Docker rm, then the container ID. So in this case, I'll go ahead and delete both of these containers like that. Instead of doing it manually with Docker rm, you could also do Docker compose rm, and it will delete all of the stopped containers that you have for that particular Docker compose file. Now, when I bring this up, or I run Docker ps-a, there are no previously stopped containers that are still existing in memory. And so if I do the Docker compose up command like this, it has to recreate new containers. And on the left-hand side, if I reconnect, type ls here, you still see that I still have these examples inside of the volume folder. They got persisted because of the volume. But if I go back to cd/ and type ls here, these example files did not persist. So these example files, they stayed per container instance that was either stopped but still existing. But as soon as you actually delete the container, that's when it actually deletes the changes that you've made to your container. And then when you rerun Docker compose up, it will regenerate a new container for you. This is something that I didn't have to deal with before because I never used, let's see, when I press Control-C on the right-hand side over here, the actual command that it is sending to Docker is Docker compose stop. So real quick, I'm going to run Docker compose up -d. So start these in daemon mode. And instead of running Docker compose down, I'll run Docker compose stop. And stopping just stops the containers without deleting them. Now, if I do Docker ps-a, I can see that they're listed right here, still taking up disk space, still persisting any changes that I've made to them. Let's go ahead and do docker compose start to start those containers back up. And now if I do docker ps, they're listed. But if I do docker compose down both runs docker compose start and then deletes the containers. So now if I do docker ps-a, you won't see the containers listed here. Maintaining sort of in your head exactly which containers are still like existing and not existing is something that I recommend you try not to do. You should just sort of treat all containers as purely disposable objects that you can delete on a whim and get rid of. And so I recommend always using, or personally, I always use the docker compose down instead of docker compose stop. But you will see online with different tutorials, people will be talking about trying to persist containers temporarily. And if you do accidentally get into a situation where you have multiple of these multiple of these containers that are hidden containers that are displayed like this, they will eat up your precious disk space that you have allocated you on the Lambda server. So this is one of the things that if you ever do run out of disk space, I'll be asking you to go through to help clear up some disk space for you. Yeah, it's a little bit more advanced into kind of the internals of how Docker Compose and Docker are working. So not 100% necessary that you understand the details of a stopped container and these hidden containers versus an actually deleted container or Docker Compose down, but potentially useful debugging things that might be happening to you during the homework. Does anybody have any questions about anything that we've talked about today? Okay, so then, yeah, as a reminder, we'll have the normal lab session on Friday, 10 to 11 a.m. And there's no like lab assignment this week, it's just the homework assignment, but that'll be a chance for you to work through the homework, get some of these issues resolved with me present. Hopefully that can make things go smoother, but totally optional about whether you attend or not. So I'll either see you all on Friday or see you next week. That's the end of class. I'll stick around for a little while if anybody does have questions and wants to ask them.